So welcome back, everyone. In this video, we will expand upon what we've learned in the previous one. And we will do so a little bit more directly than we might do otherwise, because in the previous session, you learned about the basic object types in R. So about characters, about double numbers, about integers, etc. Now, these basic object types are definitely the most fundamental and the most important in R. But they are less well suited for particular kind of operations. And therefore, some people came up with more advanced object types that are characterized by the fact that they take the basic object types you've learned before and they add some features to them and make them more useful for particular areas of applications. Therefore, it is very important that before learning about advanced object types, it's very important to learn about the fundamental basic object types in R. Once you did that, this is a great place to continue your journey into the R world. So what is it that you're about to learn in this session? First of all, we'll talk about three advanced object types that are among the most frequently used. These are factors, data frames, and tibbles. There are many more, but I guess these three are, at least from a data science perspective, the most important one, especially in the beginning. And what I would like to stress during this lecture is this relation to the basic object types discussed in the previous video, because I feel that this actually makes it easier for you to understand what is specific about these new kind of object types and why they are useful in some instances and not so useful in others, and in the end, when to refer to which of these object types. Let's tie in the topic of this section, advanced object types, to the topic of the previous session, which was about basic object types. You might remember this taxonomy of objects in R that we discussed previously. We had the big category of vectors, and then we distinguished between atomic vectors and lists. What was the main difference? Atomic vectors are vectors that only contain elements of the same type, whereas lists or generic vectors could possibly contain elements of different types. The fact that atomic vectors only contain elements of the same type makes it easy to name them, because we just name them based on the type of the objects they contain. Thereby we came up with four different kinds of atomic vectors: logical atomic vectors, which only contain the values true or false; integers, which only contained whole numbers, 1 to 3; double atomic vectors, which only contained decimal numbers, 1.0, 1.5, 2.8, etc., and character, which were atomic vectors that contained strings or words, characterized by the quotation mark at the beginning and the end. Lists, on the other hand, they could possibly contain objects of different types, so a list could contain both double, integer, and logical values, for instance. Now, what we're about to do today is to look at object types that go beyond this categorization, but they are not standing aside of it. Rather, the advanced object types we are talking about today, they take one of these basic objects and add something to it. For instance, we will talk about factors, and factors could be thought of as fancy integers. They are basically, some smart people took the object type integer, added some features of it, and thereby turned it into the object type factor. The second thing we're talking about are data frames or tibbles, which are basically fancy lists. So data frames are lists that satisfy certain properties, such that we can easily put them into the form of a table, and we can do some work with it that is very typical and defining for in the area of data science. We also talked about this issue of null, which I will take up later on. Now, here's a bit on the logic behind advanced object types. As I said, this comes a little bit from the previous session. There are many object types in R. The most important thing was to understand the basics, namely the atomic vectors, lists, and functions. This is because these basics are not only the far most common object types, therefore they were the main subject of the previous session. No, they also form the basis for everything we talk about today. This is because these advanced object types, they always somehow build upon the basic object types. Technically, take a basic object type, you add some particular attributes, and this turns it into a more advanced object type. What are we talking about today? Well, we are not talking about all the non-basic object types, because as you can imagine, there are many of them. This is because there are so many smart people who all took basic object types, added some clever attributes, and turned them into more advanced ones. But there are 2 or 3, depending on how you count them, that stand out in their prevalence and that I think are worth these elaborations of this session. First of all, the factor. The factor is an object type that has been designed to work well with categorical data. This is something that, especially in the social sciences, we encounter very frequently. Categorical data is data that can only take a pre-specified number of values, and we call these values levels. This is also a very nice example of where data science becomes political. Why? Because the very basic example or standard example for categorical data that can be coded as a factor is the gender. Typically, for a very long time, gender was a variable that was only allowed to take 2 pre-specified values, male and female. Then things have changed, and today usually gender is used as a variable that can take 3 pre-specified numbers of values, male, female, and diverse. But then again, there are also criticisms of this categorization and debates of whether actually gender shouldn't include more levels, so to speak, or whether gender can be categorical data or can be measured as categorical data at all. I don't want to get into this deep debate here, but I think it's a nice illustration of how data always has this kind of political or normative dimension. What is, however, always true, whenever you use the factor to work with categorical data, is that you need to use the function factor. The function factor is used to take particular values or another object type and turn it into a factor. And we will learn how to do that later on. Now, the second advanced object type we're dealing with today is the data frame. And I said, okay, there are 2 or 3. We will more specifically talk about the data frame and the tibble, but they're very closely connected. You can think of the data frame as a kind of table in which different variables are stored as vectors. So this is how a typical data frame looks like. We have here a table with 2 columns, one column called gender, one column called height, and this could be taken from a survey, so to speak, where people were asked about their gender and their height. This is why data frames can be thought of as like specialized lists, namely lists where each element has the same number of sub-elements. You can think of it as a list having here, in this case, for example, 2 vectors, and 2 vectors have the same number of elements. Tibbles are then a more modern variant of data frames that were invented, like Hadley Wickham, one of the people who invented them, said that, tibbles are characterized by the fact that they do less and complain more. We will talk about both of them. It's actually very straightforward to understand what tibble is once you understood what the data frame is. And since a lot of our code still uses data frames, I think it's a very good idea to learn both. If you want to create a data frame, you can use that. You can do that with the function data frame, or if you want to create a tibble, you can use the function tibble from the package tibble. As I said, there are many other advanced object types. I would say most of them are not that prevalent as factors and data frames, but that doesn't mean they are not useful. Like, for example, matrices are incredibly important thing in many areas of data science. But we're not dealing about this in details here. There are some elaborations in the course material, though. Also, durations or dates are also quite frequently used, but I wouldn't say they are as important as the factor and the data frames, which is why these two are the main subject of this session. Okay, at this point, I want to add a short digression on attributes, which you can easily skip. So you can directly go to the next video if you're not interested, but I think it can be useful to avoid some kind of irritation later on. So as I said, advanced object types are basically basic object types turned into something more fancy. How do you turn a basic object type into something more fancy? Well, you add attributes to them. And if you want to have a new object type, you need to add an attribute that is called class. Yeah? By doing so, you change the behavior of that object type when functions are applied to them. So once, for example, an integer is turned into a factor, there are certain functions that work differently on it. This is actually why these advanced object types are useful, because people thought about adding attributes such that they are behaving in a way that is more akin to the kind of data structures they are usually used to encode. Technically, and this is where I think this becomes important, is that if you add the class attribute to a basic object types, this changes only the class, but not the type. And this can lead to somehow surprising behavior in practice. So here we have our factor ff as defined right now. If we look at it, we see here that it is printed in a particular way. This has to do with the fact that by adding certain attributes to this kind of object, the function print, which is implicitly called if we just type the name of an object in the R console, behaves differently as compared in the case of a standard factor, standard integer. So here, for example, we have this line levels being added. Now, we can use the function attributes to actually understand the attributes of an object. And if we look at the attributes underlying the factor ff, we see that it has two of them, levels and here the class. And because this attribute has been added to the underlying object type integer, we here have a more advanced object type called factor. One thing might be irritating though. You encountered the function typeOf to ask R about the object type of a certain object. You might have expected that if you call typeOf it would tell you that it's a factor, but it's actually not. It will tell you not the name of the advanced object type, but always the name of the underlying basic object type. And because factors are fancy integers, typeOf will always return the term integer. You can use the function class to inquire the underlying class of ff. And this is indeed factor. So you see this here in the attributes, but if you ask R about the class of ff, you get the factor directly. Now, I do not want to delve into the details of that, because this has to do with a kind of object-oriented structure of R, and this is a little bit of a hassle. If you're interested, there is some very good literature about that. I'm just mentioning this here because, especially for beginners, it can be irritating that in the beginning you learn that typeOf tells you about the type of an object. And this is true for basic object types, but it's not true for the more advanced object types, because typeOf will always give you the name of the underlying basic class. This is not entirely useless, because this base class in many ways determines how the more advanced object types work, and sometimes irritating behavior can be rationalized by the underlying object type, but it can also be frustrating in the beginning, a little bit irritating. And I hope by at least clarifying the source of this possible confusion, I contributed a little bit to more clarity.